Section 8.2 Exponential Functions. Objective 1. Evaluate exponential expressions. In example number 1, we have 3 problems A, B, C. I wrote down the answer and the problem. So can you please use calculator and calculate, for example, part A, 3 exponent 1 over 4. And then check the answer to see if you get it right. That means you know how to use a calculator to evaluate exponential expressions. Definition of the exponential function is that f of x equals a to the x, where a greater than 0 and is not equal to 1. We learned the function before. For example, we have f of x equal to x squared. It is a parabola. And then f of x equal to x, so it gives us a linear. It's a line. F of x equal to x cubed is like a snake, right? And then f of x equal to square root of x. Square root of x I can write like x to the 1/2. Then the graph is one side. So we learned in the sections before. If you notice that this is in the exponential form also, but the base is the x. You see all of the example I just made, the base is the x. The exponent is a number, like 2, 1, 3, and 1/2. For the exponential function a to the x will be the variable. That means the exponent will be the variable. And a, the base, will be a number. Objective number 2, we want to learn how to graph exponential function. The very basic exponential function is 2 to the x. And again, you can see that the base is a number and the exponent x is a variable. The problem asks us to use the point plotting. That means we need to make table and we need to plug in the function to find the points. So we need to make some positive and some negative and also a 0 for the input. Then we get 2 to the negative 2, 2 to the negative 1, 2 to the power 0, 2 to the 1, and 2 squared. If you don't know how to calculate this number, you go back to example number 1. You just simply use calculator. But they are very easy. If you don't use calculator, you can still able to do them. For example, 2 to the 1 is 2, 2 squared is 4, 2 to the power 0 is 1. Because we have a property before that a to the power 0 is 1. And 2 to the negative 1 is equal to 1 over 2 to the 1, and that is 1/2. And it's equal to 0.5. 2 to the negative 2, so it's equal to 2 square, but 2 square in the bottom. And then we got 1/4. 1/4 is 0.25. Now we plug in the numbers. I'm gonna plug in the 0 first. So 0, 1, 1, 2, 2, 4, negative 1 and 0.5, and then negative 2, 0.25. And then we connect them. And that's it. We got the graph. And I draw the arrow because we can make positive 3, negative 3, and so on. So we observe this graph and we want to answer the domain. The domain of the exponential function is always all real number. So we can write or you can write from negative infinity to positive infinity. And the range, so we see that the graph is on above the x-axis. That means the white part is positive, so we don't have negative y. And the lowest number is 0, but it's not included, right? So it's 0, infinity. Similarly, we will do example number 3. We will also make some positive and some negative number. Then we do 1/2 to the negative 2, 1/2 negative 1, 1/2 to the power 0, 1/2 to the 1, and 1/2 square. 1/2 square is 1/4, so we get 0.25. 0.5 for 1/2 to the 1. 1/2 to the power 0 is 1. 1/2 to the negative 1 is 2. And 1/2 to the negative 2 is 2 square and is equal to 4. Then we will plug in 0, 1 first. 1, 0.5. 2, 0.25. Negative 1, 2. And negative 2, 4. And then we look at the graph and we answer the domain. The domain is from negative infinity to positive infinity. The range and the same thing. The y is positive. So we get 0, infinity.